Good morning. This is your stats sensei, Mr. Spensei, and we're here to talk about regression printouts. First off, I want to go back and say, hey, we were talking about airfare, having a flight from Atlanta and the distance in airfare. This was on a previous page 246 for note spiral. And in this particular case, I would make sure that I had this data entered into stat edit. So just make sure you have it all entered in stat edit, because that's going to tell you, we're going to use that to create the table. The table information was driven from this data. So you need to go back and enter that. So you may want to pause real quickly and get this data entered. Also, here's some check figures. And remember, you can go stat calc one variable statistics and check L1. And there's my sample mean at 853.7 and my sample standard deviation of 497.8. And then the other thing is we can go stat calc one var stats and do the same thing for L2. And we get 244.33 and a standard deviation of 56.37. But it'd be helpful to have that information in so you know where these table values came from. So first off, when on the AP statistics exam, you're almost guaranteed that they will give you a table, and it's unlikely that they give you a list of data. So it's unlikely you get a data list like this. It's almost assured that when you see this, it's going to be in this type of table format, which is kind of nice. You don't have to worry about data entry errors, et cetera, but we need to learn how to read the table and find the information. Well, we know that we were talking about, in our case, we had distance and we had airfare. And those made up our X and Y's. So the question is, can I find that information from this printout? And the answer is partially. It will almost always give you, under the variable, you'll see the word constant. And the nice thing about constant, means this is your y-intercept. And this is my input variable. This is my explanatory variable. So in this case, my explanatory variable happens to be distance, and it'll always be there, okay? And then it also asks for the response variable. Well, in this table, I don't have it. I would need a paragraph or some sort of sentence stem or prompt to tell me. So in this case, my airfare is my response variable. We knew that from prior, but that's not on the table itself. So next to distance, I see a value. That value is 0.0786, and that's the slope of the regression line. And please remember, our slope is really 0.0786 over 1. So $0.0786 for every 1 mile traveled. And it really helps if you will write it as a fraction. You're less likely to make an interpretation error. It also says identify the y-intercept. Well, guess what? We just already said that the constant represented our y-intercept. And so there it is, 177.215. And then it says write the regression equation. And our equation is just going to be the y-intercept plus our slope. So there it is. Now, I've entered all that data into the calculator, and I want to do this fairly quickly. So let's go stat and arrow over to the word test. And we're going to run a linear regression t-test, which happens to be letter F. I'm going to press enter. My data is in L1 and L2. My frequency should be 1. And then it's give me a choice whether it's going to be not equal, less than, or greater than. Almost guaranteed to be not equal. And if they didn't tell you anything, it is not equal. And all of these tables are done as a not equal. So I'm going to go ahead and do that. And then I'm going to store my regression equation. And again, this is not intuitively obvious. So you need to go alpha, trace, enter. And we get a ton of information. All right, we get a t-statistic, which we haven't talked about for regression, a p-value. We have our degrees of freedom. We have our slope, we have our y-intercept. We also have our slope. We have our S, and we'll talk about what that is in a moment. R squared, and R. So we have a ton of information that shows up when we do that. All right, so the next thing said, so I wanted to show that because, well, basically all this, most of this table information just popped up when I ran that. And real quickly, that was stat, test, all the way down to letter F, linear regression t-test, L1, L2, and we had not equal, and then we went alpha trace to store it. All right, so that's where that information comes from, and we'll look at it in just a moment. It says calculate the sample size. Well, we know based on our data list, we could calculate the sample size and go, hey, you know what? Our sample size was 18. We have 18 values, or 18 pairs, 18 X and Ys. Well, here we have a 16 and 1, and this is DF for degrees of freedom. So this is your degrees of freedom. And it turns out that for regression, degrees of freedom equals n minus 2. All right, so degrees of freedom is n minus 2. So we look at our residual, and it'll always look at the residual, which is 16. And we have 16 plus 2, so there's our 18. Okay, so once again, that backs up our sample size being 18. And we knew that because that's how many data pairs we entered. And once again, you get that from your residual 16 plus 2. Then it also asks you for the standard deviation of the residuals. Fact of the matter is, you can pretty much ignore all this work right here. All right, but we're going to go through it anyway. Well, S is my standard deviation of the residuals, which is 41.82. When we ran the calculator, when I scroll down, we passed up S, and there it is, 41.82. So there's my standard deviation of the residuals. Now, I can also get it a couple other ways, and I'm going to tell you that in my class, I'm going to expect you to know how to do this. So what you would do is you take 27,980 and divide it by 16. So let's take that. 27,980 divided by 16. And that's the sum of the squares of the residuals. And we divided it by the degrees of freedom, and we got a mean square, all right, of 1748.75. There's rounded a little differently, but whatever. And we're going to go caret. We're going to take the square root of that. We'll take the square root of that, and there it is, my 41.82. And that's what it shows here. Sum of the squares of the residuals, the sum of the squares of the residuals. Well, apparently I don't have, 27,980 divided by 16 equal this. And then I took the square root of that, and that gave me my 41.82. All right. So once again, 27,980 divided by 16, I took the square root of it, and I got 41.82, which is the standard deviation of the residuals. The next thing it says, well, okay, from the table, how can I calculate a t-statistic from the table? Now, fact of the matter is they actually gave me the t-statistic, but I'm likely not to do that to you. I'm likely not to let you have that value. I'm likely to say, hey, you need to know that you go 0.0786 divided by 0.0204. So let's try that. 0.0786 divided by 0.0204. And sure enough, we end up getting a t-statistic of 3.8. I got 3.85. They have 3.86. That's some rounding. So that's pretty close. And while we're doing that, let's go back and rerun this test, stat test, linear regression t-test, not equal, and alpha trace. And when we scroll, we see 3.858 or 3.86. We also see our p-value. And we also see that they gave us the p-value as well. But what happens if all that they didn't give me this information? What happens if they didn't give me this? Could I still calculate a p-value? Well, the answer is yes. All right. So in order to calculate the p-value, you're going to have to go, well, I need my t-statistic. Well, how do I get my t-statistic? 0.0786 divided by 0.0204 gives me 3.86. All right. So let's think about this for just a moment. When we're working with a t-statistic, it's centered at 0. And we ended up with a t-statistic of 3.86. So we're looking for this area. But when we're talking about regression, it's almost always going to be a two-tailed test. Notice I said almost always. It's not always, but almost assuredly, it's a two-tailed test. And for the table value, it is. So it's like, okay, what do I know? I know this, and I also know that my degrees of freedom was 18 minus 2, or 16. So at that point, I can go, you know what? Second vars, TCDF, 3.86, upper bound, infinity, degrees of freedom, 16. Then all of a sudden I look and I don't get that value. Why? Because I ran this as a one-tailed test here, so I need to come back and double it. All right, and there it is, 0.00138, which runs up to 0.0014, which is why here I said you need to double your p-value, all right, because this was a two-tailed test. The next thing, it asks for the correlation coefficient. Well, when I look at the table, they don't give me the correlation coefficient, but they do give me R squared. And they also give me R squared adjusted. For AP statistics, this is just here to confuse you. We will not use that as an answer. So R squared is 48.2 or 0.482. And I should take the square root of that. So 0.482. And I'm going to take the square root of it by raising it to the half power. And I get 0.6942. So I end up getting an R of 0.6492, but I need to check one other thing. I need to look at my slope. In this case, my slope is positive, so my correlation coefficient is also going to be positive. All right, so the correlation coefficient has to have the same sign as the slope. If it's negative, you're going to need to put a negative sign there. Now, please remember, we entered all that data. We went stat test, linear regression t-test. We went all the way through the thing. When we scroll down, it gave us both our coefficient of determination and our correlation coefficient. But that's only because we have the data. You need to be able to know to take the square root of 0.482 and then get the sign and get the sign of the slope, which in this case was positive. So we have a positive correlation. Okay. All right. So that's how you read the table. And it's going to be really important you know how to break that down. Likely in my class, you're likely not to have this value, this value, this value, or that value, because you should be able to go 27,980 divided by 16 gives me this, take the square root of that, and I get this. And you should be able to go this divided by this equals this, and know that if it's two-tailed, I can run a TCDF to get that. All right, I hope that helps with printouts. Thank you for watching. And the next video, we'll actually go through the mechanisms of running a hypothesis test. Thank you so much. See you in the next one.